All right, here we go. Question 14 from our Calculus 1, homework number 1 in WebAssign. They want us to determine what is wrong with this equation. And we've got some choices here. So I want to open this up in my notepad. I've got the equation copied down. And I want to show you what is wrong with this problem, okay? So let's consider x is 4. If I try to evaluate the left-hand side, I'm going to get an undefined situation because that's going to give me a 0 in the denominator. So x cannot be 4 on the left-hand side, but on the right-hand side, if I plug in x is 4, I actually get 9. I get an answer. So trying to say that these two are equal is incorrect because they are not equal when x is 4. So which one of these answer choices is correct? Let's see. The first one says that the numerator would not factor like this, but it does. This is actually the correct factorization of the numerator. And that has nothing to do with the fact that the first part is undefined at 4. All right, second, the left-hand side is not defined for x equals 0. Nope, the left-hand side is not defined for x equals 4, but the right-hand side is. There it is. You cannot evaluate the left-hand side at 4, but you can evaluate the right-hand side at 4. So it's option 3. Now, part B. In view of part A, explain why the following equation is correct. You see, the minute that you throw in the limit doesn't care what happens at 4. It only cares what you approach. And so we're going to show you how this actual equation is true once you include the limits. All right, so considering this left-hand side with the limit included, and we're going to use that factorization that we looked at just a second ago to factor the numerator as x plus 5, x minus 4. Notice that when you factor, you can get this common factor to reduce out. At this point, you can then simply evaluate your expression at 4, and that will give you the limit as x approaches 4. Again, once you eliminate the undefined situation, you can evaluate the limit with direct substitution. 4 plus 5 is 9. And now if we look at the other side, the limit as x approaches 4 of x plus 5, again, if I open that up, you can see here was the other side. There is no undefined situation here. We can evaluate and get the same answer. Again, I want to re-emphasize that the limit doesn't care what happens at 4. It only cares about what you approach as you get close to 4. And so let's see which answer choice applies. It's not the first one because this first expression is actually not continuous at 4 because it's undefined. Since the equation holds for all x not equal to 4, it follows that both sides of the equation approach the same limit. That sounds pretty good. The equation follows from the fact that the equation in part A is correct. No, the equation in part A was not correct. And it's not none of these, it's number 2. Since the equation holds for all x's not 4, that means x's that approach 4, not including 4. And so let's see if those answers are correct. Bam! Got it. And that's going to conclude that problem. So if you have any questions or comments about anything covered in this video, please feel free to leave those in the comment section below, or you can text me. And thanks for watching.